It is, ma'am. Yes, ma'am.
Yeah. So last time we have learned about the atomic radius, right? Yes. So what you understood about the atomic radius, beta? In a group and in periods, how it vary?
Ma'am, I think I have missed this class, ma'am, because I don't know about it, ma'am.
Oh, you were there. You were there. I think
I'm
you got
sorry.
disconnected meanwhile, I guess. Fine, no issues. So atomic radius means what? A distance from the nucleus of an atom to the outermost shell, which held the electron inside it. Right? This
Oh,
distance is called as what?
yes, ma'am.
Yeah,
Atomic radius. Yes, ma'am.
radius. Radius for the singular form. And if you have to like say more radius together, that is
It's
radii.
red eye.
Okay. Now, what you have to keep it in your mind about it, there are these different types of atomic radius, ionic radius, then metallic radius, covalent radii, and the van der Waals radii. So what is the difference in between all that? You need to keep it in your mind. Fine? Yeah?
Yes, ma'am.
Fine. So we'll move little down. Atomic radii. See here. What is the atomic radii? The atomic radius may be defined as the distance as the distance from the center of the nucleus to the outermost shell containing the electrons. Depending upon the nature, it's classified as the covalent radii, van der Waals radii, and the metallic radii. So about the covalent radii means what? When any molecule is formed due to the covalent bond, right? Suppose this is atom A, this is atom B. Both they have shared the pair of electron in between them. So half of the distance in between, that is nothing but what? Your covalent radii. Mostly, we like covalent radii, we consider it for the similar molecule, similar atomic molecule. Means both atoms would be same.
When it's,
The-
for example, calcium, sorry,
yeah,
chlorine,
yes, yes. Or
hydrogen, hydrogen.
what should be B? Here they have given the example of chlorine because Cl2
Ah,
molecule,
yes.
its bond length is what? 198. And it's exactly half if we count, that is nothing but 99 picometer. So chlorine has atomic radius that is what? Covalent radius, not the only atomic radius, it's a covalent radius that is 99 picometer. Okay. Suppose sometimes in any examination, if they give you the atomic radii or they give you a covalent radii and they ask you to calculate its atomic radii, covalent radii of a particular single element, that time you have to do it exactly half, right?
Yes,
For
ma'am.
that reason, you should be aware what is the covalent radii. Fine. Now we are going to move towards the van der Waals radii. What is this? Hmm? Half of the internuclear distance between two similar adjacent atoms belonging to neighboring molecules of the same substance in the solid state is known as a van der Waals radii. Means substance should be in which state first? Condition is
It should be
solid state.
solid.
It should be solid state. Correct? Second thing is what? Substance should be same. Right?
Yes, ma'am.
Substance
Both of them should be the same one.
same. And among their molecules, whatever bond would be there, that is a van der Waals bond. Fine. For example, suppose you take a water molecule. So this is H2O molecule. Here also it would be H2O molecule.
It would be
Right?
nice form.
They have a force in between, right? They attract each other with what? Sorry, van der Waals force. Correct?
Yes, ma'am.
And whatever half distance in between, that half distance is nothing but what? Van der Waals radii. Understood?
Yes, ma'am.
Van der Waals radii. I hope you understand about it. Now,
Yes,
next
ma'am.
is what?
Understood.
Similar way you have to learn about the metallic radii as well. So what is the metallic radii? See, what is given here about it? Let me take it down. Yeah. Here they have given you half distance between the center of nuclei of two adjacent atoms in a metallic crystal is known as a metallic radii. If your crystal is a metallic crystal, means the atom which exists nearby, both are metals. Correct? Yes or no?
Yes, ma'am.
And in those atoms, whatever bond is there, that is a metallic bond, right? And if you take a half distance among them, I'm particularly giving here positive charge because metals are electropositive in nature.
Yes, ma'am.
Yeah. So when you divide it by half, you will get what your metallic.
Metallic red eye.
Got it? Fine. As we move from the left to right in a period, atomic radius decreases. This you have to keep it in your mind, and it's very, very important, right? Due to increasing effective nuclear charge. So what is the effective nuclear charge? You have to keep it in your mind. Like whenever we move in a period, what we have learned earlier, are you remember? When we move along the period, we have to fill the extra electron in the
Yes, yes, ma'am.
that particular shell, correct?
And the last period, it is completely filled.
Yeah, we start the filling of electron in same shell at the start of the row, and at the end of the row, what we have to do, end of the period, we have to complete it, right?
Yes,
Means
ma'am.
each case we have to increase the electron, right? For the first period, if you see this is a hydrogen atom, here would be first electron, and if you see about the helium, here would be how many? Two electrons,
Two
correct?
electrons. Yeah,
This is
it
a
gets
hydrogen
increased.
and helium, correct? Very
Yes.
basic example I'm going to give you. Now, what you understand about it? As we move left to right in a periodic table, in the same way, we have to fill the electron in the different shells. Same shell, we have to fill the number of electrons. Here, number of protons present in the nucleus try to attract the electrons towards itself, right? Yes or no?
Yes, ma'am.
It has a it has effective nuclear charge. The charge which possessed by the nucleus is called as what? Effective nuclear charge. Okay. What sort of charge it will be?
Effective nuclear charge.
Positive nuclear charge. And the charge on the electron is what?
Negative
Yeah,
nuclear charge.
negative charge. So there would be the positive negative attraction, correct? Yeah,
Yes, ma'am.
yeah. And as this number of electron is increases, these electrons attract more towards the nucleus. Understand? As number of electrons are filled in each and every group, means when we travel left to right in the period and we move across the groups, what happened? One electron in each group is being added, correct? In
Yes,
same
ma'am.
shell. And hence it experiences a effective nuclear charge, and that attract that particular those extra electrons towards the nucleus. In a result, the shell is shift little towards the nucleus or get contracted. Understand? And hence,
Yes, ma'am.
when we travel left to right in a periodic table, what happened when we travel left to right in periodic table?
The
Atomic
atomic radius will decrease and the effective nuclear charge will increase more.
radii would be decreases. This is also called as contraction of shell. Okay.
Yes,
More
ma'am.
easily you will understand it in your lanthanide actinide as well. Lanthanide contraction, actinide contraction. We have to see, but then that we will see for the F block later. Clear?
Yes.
Fine. Now, see, next is the ionic radii. Sorry, not only this, we have to learn about the another one point that would be vary of atomic radii across the group. What happened in a group when you move down? That day I have explained. Mhm. Come on, tell me. Here are
Yes,
the
ma'am.
participants. Wait a minute. Somebody have. Good afternoon, Dhananjay. Okay, somebody else is okay. Rest all. Jaswant is also there.
Good afternoon.
Okay, fine. Good afternoon. Now, another thing is what when you down the group, okay, in a periodic table, what happened to the atomic radius? Mhm.
It
Decreases.
decreases.
Yeah, I will write it here after hydrogen, after that lithium, sodium, right? Then calcium, no, not calcium, potassium, K. Only this I will write, 3. So what happened in this? If you go down the group, here will be how many shells for the hydrogen? One shell with one electron, correct? And
Yeah,
lithium,
ma'am. They all have the same valency,
yeah,
but
two shell. First
yes,
will be completely filled and one electron is there into the next shell. When you see the sodium, there would be what again? Sodium nucleus, one shell, two shell completely filled with the 8 electrons, second shell, right? And third shell has only one electron, correct? And what about the potassium? Potassium has two completely filled octet shells, and one electron would be into the next shell. Means there would be how many? 4 shells in with respect to potassium, isn't it? Yeah. See, its electronic configuration would be what? 1. Its electronic configuration 2 comma 1. Its electronic configuration 2 comma 8
eight,
comma 1.
eight
And it's
comma.
2 comma 8 comma 8 comma 1. Right. So you will come to know the number of shells by this K, KL, KLM, here KLMN. So when you move down the group in the periodic table, number of shells is added into the next element, isn't it? In a group, when you move down. Yes. And as shell is, means number of shell is increases, distance from the nucleus to the outermost shell is also increases. Correct? Yes
Yes,
or
ma'am.
no? Distance from the nucleus and the outermost shell is also increases. Hence, atomic radius is increases. So there might be a question in your mind, ma'am. Just now you have explained about the effective nuclear charge. So why this is not applicable to groups? So this is not applicable because the electrons which are in influence of that nuclear charge, that much only affected and get contracted towards the nucleus. Those are farther and away. They are in the shielding effect. They do not
Okay.
get attracted towards the nucleus, and hence the distance goes on increasing. Hence, when you travel down the group, what happened? Atomic radii increases.
Increases.
Yes. Understood?
Yes, ma'am.
Yeah. Dhananjay, Jaswant, are you understanding?
Yes, ma'am. We are understanding.
I'm not able to hear you. Can you speak loudly?
Yes, ma'am. We understood.
Okay, very good. Thank you. See, we'll move forward now. Ionic radii. What is the ionic radii? So ions are how many types? Can you tell me? How many types are ion you know?
Two.
Mm-hmm.
Two types:
2 types. Very good. First one is
cation and anion. Okay.
positive ion. That is called as what? Cation. Right. Another one is
And negative ion,
negative
which is
ion.
anion.
Yeah. And it is anion. Correct. Now, logically, you tell me which has more atomic radius. Cation would have more atomic radius, or anion would have more atomic radius. Tell me about the logically what you understand on the basis of that.
Anion will have
Anion will have.
more atomic radius
Why it is so? See what
because
logic. Yeah. What
because
logic?
when it will take electrons, it becomes negative. So hence, like if when it keeps taking electrons, it uh, increases its number of shells also. So the atomic radius will increase.
All the time shells won't be increases, right? Sometimes only it can be increased. Every time shell won't increase, but then when you add up with the electron, negativity of the ion would be increases, right? And shielding effect is also increases due to more electronegativity, right? And hence it doesn't get contracted towards the nucleus. And hence anion has a more atomic radii as compared to cation. Means like trend would be what? Cation has less atomic radii as compared to neutral atom, and neutral atom has less atomic radii as compared to anion. Got it? Yes. Why this is? Because in a cation we remove electron. When we remove electron, what increases? Effective nuclear charges increases and it get contracted towards the nucleus. In neutral, it remains as it is, so it won't affect. But then in anion, when you add electron, your shielding effect would be increases. Understand?
Okay.
And hence,
Yes.
what happened? Atomic radius is increases. Clear?
Ma'am, once can you again explain shielding effect?
Yeah, why not? The shielding effect means what? This is suppose an atom, right? It has 2 electron over here. It has 8 electron over here. And here suppose 1 electron or 2 electron, whatever it would be. So here nucleus has a electropositive charge, correct?
Yes, yes, ma'am.
Right. And this electropositive charge has a capacity to attract the electron towards itself because electrons are negatively charged.
Yes, ma'am.
Now what happened? Number of protons, we know that number of protons and number of electrons have a same charge on it, right? So
Yes.
how many number of protons are present into the nucleus, that many electrons only would be influenced by the effective nuclear charge, correct?
Yes, ma'am.
Suppose here are the 10 protons, so only 10 electron would be affected. These 10, I'll use different colors so you'll understand. Suppose this 10 electron only would be get affected by the 10 proton. But then these 2 electron, they are not in the influence of your nuclear charge. And because of that, they are get shielded. And this is called as shielding effect.
So whatever atomic radius will be calculated is up to the last two
No, no, no.
electrons.
Atomic radius would be up to last shell. But then this won't get contract towards the nucleus. Last shell won't get contract towards the
Yeah, yeah,
nucleus
that's
due to
what, ma'am. Yes,
shielding
ma'am.
effect. Understand? And hence atomic radius would be more with respect to anion
Yes,
because
ma'am.
it has more shielding effect. And if you see about the cation, in that you remove the electron. When cation generate, tell me.
When we
When
give
you
away
remove
an
the
electron.
electron from your neutral atom, correct? Yes or no?
Yes,
Shall I
ma'am.
explain you with the example? Shall I explain you with the example? Guys, come on.
Okay, ma'am.
Tell me.
Yes, ma'am.
Fine, wait. I'll let you know. Don't get confused, okay? Suppose I'm going to write here. We'll take 2 examples of sodium and then we will take for the chlorine. Sodium atomic number is what? 11,
11.
correct? Electronic configuration 2, 8, 1. Yes?
Yes, ma'am.
So I'm going to draw its structure. It has how many? 11 protons. Because as atomic number is reflect is nothing but number of proton or number of electron. And there would be how many? 12 neutrons inside the nucleus. Correct?
Correct, ma'am. Yes, ma'am.
Yeah. There would be 2 electrons in K shell. Then here 8 electron in the next shell and 1 electron over here. Right? If I have to generate the cation, this 1 electron would be given. Right? Yes or no?
Yes.
And as we know that number of proton in a neutral atom, in neutral atom what? Number of proton is equal to number of electron.
Electron.
Correct? Means it should be 11 proton should be equal to 11 neutrons. I'm sorry, that will be electron. Correct? Once this one electron has been lost by this atom, there would be what? 11 proton. That compensate how many? Only 10 electron. Yes? Hello? Hello?
Yes, ma'am.
Am I audible?
Yeah.
Yeah.
Yes,
This
ma'am.
11 proton would be compensate how charge for what? Only 10 electron, right? So as we know that number of amount of charge on one proton is equal to amount of charge on one electron with opposite charge, right? So they can cancel each other, nullify each other, only remain what? One proton as it is, because one proton plus 10 proton is equal to 10 electrons. So this 10 proton can be compensate the charge on 10 electron, but then one proton is extra in the nucleus. So it has more positive charge, correct? As compared to the number of electron in their shells by losing this electron. Yeah. Hello. Hello.
Yes. Yes.
Yeah. Understanding. So what happened because of this? Because of these positively, because of this electropositive nucleus, electrons, less electrons, those are just tens, that get influenced and attracted more towards what? Nucleus. And hence cations have small radius as compared to neutral atom. Because in neutral atom, how many protons are there? 11. In cation, there are only, sorry, 10, in cation only 10 electron. In your neutral atom, there would be 11 electron. Got it? Yeah. Shreyasi, are you there?
Yes,
Hello?
ma'am. I'm there, ma'am.
What happened? You're not responding. I thought like you left or you got disconnected because
No,
yesterday.
ma'am. I'm writing, ma'am. That's why.
Okay, okay. Are you clear about it? See,
Yeah,
in
ma'am.
nucleic
Yes, ma'am.
atom, there are how many? 11 electron that compensate the 11 protons. So both can nullify each other.
Yes,
Atomic
ma'am.
radius would be normal. Correct?
Yes,
But then
ma'am.
when you see in a cation, one electron from the outermost shell would be lost. There would be only 10 electron to compensate the charge on 11 proton.
11
And
proton.
hence, these 10 electron get contracted or get attracted more towards the nucleus as compared to your neutral atom. And hence, cation has a small radius as compared to neutral atom. Got it?
Yes, ma'am.
Yeah. Similarly for the chlorine, because we are going to see now for the anion, right?
Yes, ma'am.
Now chlorine, its atomic number is 17, right? Yes or no?
Yes, ma'am.
Electronic configuration 2, 8, 7, correct? So how am I going to draw? Here would be a nucleus which consists 17 protons, right? Suppose there would be 17 neutron as well. Here it is 2 electron. Then here it would be 8 electron. And in the last shell, there would be 7 electron. It's not a perfect shape, but then you please consider it, okay? It's a 7 electron. Now to complete the octet, it may receive 1 electron from the outer source, any outer source. So it becomes 8 electron, right? In a neutral atom, there would be what? 17 proton, compensate 17 electron. But when it convert into an ion, what happened? One extra electron would be added into the outermost shell. So you will get what? 17 proton to compensate with 18 electron. So what is extra here? Negative charge, right? Yes or no?
Yes, ma'am.
Negative charge would be extra. And hence, this one electron will not get attracted towards the nucleus. How it happened into the neutral atom when there would be only 17 electrons, right? Yes or
Yes,
no?
ma'am.
It undergoes what? Which effect? Shielding effect,
Shielding effect.
right? It influences with the shielding effect, and hence what happened? Atomic radius would be increases as compared to your neutral atom. And hence I said you what? Cation has less
has
atomic radii as compared to neutral atom, which has a less atomic radii as compared to anion.
an ion.
Got it?
Yes, ma'am.
Clarified? Yeah. Any one of you have any query?
No, ma'am.
No, ma'am.
Dhananjay has been disconnected or what? Fine. Now, we are going to back to our shared screen again. Ionic radii, what is given to you in the C? The ions formed by the loss of one or more electron from the neutral atom are known as the cation, right? Then that is a positive ion. When electron is added to the neutral atom from the anion, okay, and the effective distance from the center of the nucleus of the ion up to which it exerts the influence on the electron cloud is known as the ionic radii. See, what is the definition for ionic radii? This would be the definition for ionic radii. If you don't know, please note it down. The effective distance from the center of the nucleus of the ion up to which it exerts its influence on the electron is known as the ionic radii, or electron cloud also you can consist. Fine. Because everyone is aware, like we can't see the electron, right? It's too small to see. So we consider it as an electron cloud. Fine. So this
Yes,
is
ma'am.
the definition. Please note it down. The effective distance from the center of nucleus of the ion up to which it exerts the influence on the electron cloud is known as the ionic radii. And one more important thing you have to keep it in your mind, like cation has a less atomic radius than that of the neutral, so neutral atom, and which has a less atomic radius than anion, right? And the ionic radius or radii change in the same trend as the atomic radii. Means it increases, so it decreases left to right in the period, increases down the group. Got it?
Right, ma'am. Yes, ma'am.
Fine. We'll move down.
Ma'am, will you also like share these notes as a resource in WhatsApp?
Yeah, if you want, definitely I'll upload it.
Yeah, ma'am. Please do.
Yeah, sure, I'll upload it. Fine. Now the next point we are going to learn about the ionization enthalpy. Fine. So what is the ionization enthalpy? What do you mean by ion formation? Just now we have seen what it is. Mhm. What is the ionization? Means either the removal of electron or maybe addition of electron.
Yeah, yes, ma'am.
So there are the two types of enthalpies. First is the ionization enthalpy, another is the electron gain enthalpy. The meaning of gain, everybody is aware, means taking up the electrons, right?
Yes, ma'am.
Yeah. And ionization enthalpy. Ionization enthalpy is related to the removal of electron. Okay.
Yes, ma'am.
And electron gain enthalpy is related to gain of electron. So these things you have to keep it in your mind. First of all, the basic difference in between two. What is ionization enthalpy and what is electron gain enthalpy? So ionization enthalpy means what? The amount of energy required when an electron is removed from the outermost orbit of an isolated gaseous atom is known as the ionization enthalpy. Means how much energy you would require to remove one electron from the gaseous state of the atom is known as what? Ionization enthalpy. Correct? Yes or no? So when we go from left to right, means like energy would be increases or decreases. When we move down the group, energy would be increases or decreases to remove an electron from the outermost shell of an atom. That logically you have to give me answer. Come on, tell me what happened. When what happened in a period left to right, whether it would be increases or decreases.
Decrease.
Mhm. Yes.
The radius, ma'am.
Acha, come on, tell me about radius first. What happened about radius?
When we go from left to right,
Uh-huh.
it
Energy
decreases.
means like I have to detach an electron from the outermost shell. Then it will be what happen? Energy would be increases or decreases?
To detach again, it will be increasing
Increasing? Yeah?
energy.
Decreases. Dhananjay said decreases. Dhananjay decreases in a period? Okay, wait. I'll explain again this part, okay? It's very interesting. See, now here, in a period, what you know about the atomic radius, tell me. In a period when I move left to right, atomic radius decreases, correct? Right? Means distance of nucleus and the outermost shell is also decreases. This distance is what happened? Decreases. Correct?
Yes, ma'am.
Right. Means it goes more and more closer to nucleus.
Closer to the nucleus. Yes, ma'am.
Yes. Means it is in the influence of nuclear charge. In influence of nuclear charge. Correct? It is difficult to remove one electron when it in the influence of your nucleus charge or nuclear charge, right? Because they are bound to each other, isn't it? And atomic radius left to right goes on decreases. Means these electrons are get attracted more and more left to right when you move into the periods, right? Towards the nucleus. So it is very difficult and hard to remove. And to remove it, you require more energy, right? Yes or no? You remove, to remove the one electron from the outermost shell, you require what? More energy, isn't it? Hello, are you there? All four of you? Three of you, sorry.
Yes, yes, ma'am. Yes, ma'am.
Yeah,
Yeah, ma'am.
yeah,
I was speaking on mute, ma'am. Yes.
yeah. What happened? Atomic radius left to right goes on decreases. So these electrons come closer to nucleus. They are in the nuclear influence of the nuclear charge, right? So when they are in the influence of nuclear charge, it is difficult to detach or remove, and it require more energy. So your ionization enthalpy when you move to right,
The
is
energy will
increases.
increase. Yes, ma'am.
Why increases? Because you require more energy to detach the
One
electron.
electron.
Those goes more and more closer to nucleus due to reduce into atomic radii. Clear? Understood? Now trend into the your group. What it will be down the group, top to bottom. When we move top to bottom, what we know, one extra shell has been added.
Yeah. Yes, ma'am.
Correct? Yes or no? Yeah.
Yes, ma'am.
One extra shell has been added and the electrons would be far away from the nuclear charge, right? Or nuclear influence. And because of that, when, as we know that atomic radius increases, we require less energy to detach the electron. Those are not in the influence of nuclear charge, correct?
Okay. Right, ma'am. Yes, ma'am.
Nucleus, suppose this is a nucleus, first shell, it may require certain energy to remove electron from first shell. Second shell will require less energy as compared to first shell. Then third shell when increases, it requires less energy because distance from the nucleus is in increases and the electron, those are so farther, they are not into the influence of nuclear charge. And that can be easily removed, right? And hence it requires less energy. And hence your ionization enthalpy when you move top to bottom in the group would be decreases. Got it? Yes, as atomic radius has been increases top to bottom into the periodic table, your ionization enthalpy goes on decreases because it requires less energy to detach the outermost electron. Those are not in an influence of nuclear charge. Clear? Shall I erase this or I need to keep it? You are writing.
Yeah, done, ma'am.
Fine. I hope you understand this.
Yeah.
Fine. Give me a while. Let me share the first previous screen again. I think only ionization enthalpy, electron gain enthalpy and the electronegativity. These 2 points are remain, and the next period we will start with the question answers on this topic. Okay. Yeah. Electron gain enthalpy means what? Electron gain enthalpy is nothing but what? Gaining of electron. See here. Electron gain enthalpy is defined as change in enthalpy which takes place when a gaseous atom gain an extra electron to form a monovalent anion in the gaseous state. For example, neutral chlorine when converted into Cl minus 1, correct? By gaining one electron. So what would be the change happen in the enthalpy? That is nothing but your electron gain enthalpy by accepting one electron in its outermost shell in a monovalent anion. Okay, and it happened into the gaseous state. Now electron gain enthalpy increases across the period while it decreases down the group. It is completely opposite to your ionization enthalpy. Why? Because in this case, we gain the electron and in the previous case, we remove the electron. Got it? Hello? And hence it is vice versa. Clear?
Yes, ma'am.
Right. In this case, we gain electron and in previous case, we were losing electron. So whatever trends followed by the ionization enthalpy, a total reverse trend would be followed by the electron gain enthalpy. I hope all of you understood, right? If not, then logically later you please try to connect it. See here, chlorine has a highest electron affinity than the fluorine. Here it's written. Fluorine has a highest electron affinity than the fluorine, though fluorine is more electronegative element in the periodic table. So this is quite exceptional case. You need to keep it in your mind. Next is electronegativity. Fine. So electronegativity is a tendency of an atom to attract the shared pair of electron towards itself in a covalent bond. Then suppose A and B, these are the two atoms. They have shared a pair of electron, but then this shared pair electron is get attracted towards B more. So what we can say, B is more electronegative as compared to A. Got it? Yes or no? So what is the electronegativity? It is a tendency of an atom to attract the shared pair of electron towards itself in a covalent bond. Fluorine is a most electronegative element, while cesium is the least. So like these names also you need to keep it in your mind. Maybe in MCQ they may ask you. Fine. So in the period left to right, electronegativity increases because we know that the first element here it would be hydrogen, then the lithium, and the last they would be fluorine. So fluorine is the highest electronegative element, right? So you would understand when you travel left to right, what happened? Your electronegativity goes on, increases. And when you travel top to bottom in a group, electronegativity decreases. Fine. Clear? Yeah? Hello?
Yes, ma'am.
Fine. Fine. I hope all three of you understood the concept of trends in a periodic table. Okay. If anything else there, which I supposed to share with you about it, definitely I'll come with a new content. But then in next period, we are going to solve few problems on the basis of this chapter. Okay. Fine.
Fine, ma'am.
Yeah. So it's 4:30. I guess you have to join for your next class within 5 minutes.
Yeah,
So
yes.
I'll end up the class. and try to join on a time every day, student. Okay. I don't want
Yes.
you should miss any sort of content. Okay. Take care,
Okay, ma'am.
students. Till the time, bye. We'll
Thank you,
meet
ma'am.
you again.
Bye, ma'am.